Okay, welcome. This is Algebra 1, my first period class. I'm doing this for the first time, so it's probably going to be kind of humorous. I'm a one-man show doing my own filming and working out these problems as we go. Hopefully this will get you through while we're home on our hurricane day. We're going to start very, very simply with fractions. Fractions are parts of a whole. You have a numerator and a denominator. In this fraction, 3 is the numerator, 8 is the denominator. We talk about 3/8. It means that we had 8 parts originally, but to make a whole thing we had 8 parts, but we only have 3 of those 8. 3/8 is the fractional part. We want to talk about prime numbers. Do you remember factoring things down into their prime factors? If you did Abeka math, you used to make these great little factoring trees. If we were to factor down the number 12, we would find any two factors. Factors are those things that are multiplied together to give you a product. Any two factors of 12 would be 2 and 6 are two good ones. 2 is prime. Remember that prime means nothing else can divide into it except itself and 1. So you've got 2, but 6 can be divided down into 2 and 3. So we find that the prime factors of 12 are 2 and 2 and 3. If you remember that little skill, that'll really help you in dealing with fractions and reducing them. Now we want fractions to be down into what's called the simplest form or lowest terms. 4/8 is a fraction, but it's not in its simplest form. If you write each of the numerator and the denominator into prime factors, then it's very easy to see how to reduce this. We can rewrite 4 as 2 times 2. And we can rewrite 8 as 2 times 2 times 2. Then these will cancel, and what we have left is a 1 over 2. In other words, the fractions 4/8 will reduce down to 1/2. You could have 4/8 of a pie or 1/2 of a pie. It's the same amount of pie, just different numbers that we use to represent it. That's taking a number down to its lowest terms. That skill is going to help you when we are adding and subtracting fractions. Let's go ahead and practice. Let's simplify this fraction. Let's put it into lowest terms. It's 10/16. Now you may look at that and already know what could be factored out of it. Or we can rewrite this into prime factors. 10 rewrites as 2 times 5. I'm using that dot as times to indicate multiplication. 16 can be factored down to 2 times 8, and we know that 8 will go down to 2 times 2 times 2. So this is 2 times 2 times 2 times 2. That's how 16 gets written in prime factors. The 2's cancel, and what we have left is 5 in the numerator, and 2 times 2 times 2 in the denominator, 5/8. 10/16 is equivalent to 5/8. They're the exact same amount of something, they just use different numbers to represent it. This is in its simplest form or lowest terms. Now we'll talk about fractions as proper, improper, and mixed numbers. There's nothing improper or incorrect about an improper fraction. I'm not really sure why that term is used. A proper fraction has a smaller numerator and a larger denominator. For instance, 1/2 is proper. The numerator is smaller than the denominator. I'm probably writing right on the glare there where you can't see. Improper is where the numerator is larger than the denominator. In other words, 9/4. In our example of 1/2, we have less than one whole thing. If I have half of a cookie, I only have one of the two pieces. I have 1/2 of it. But 9/4 indicates that I have more than one whole thing. Then there are mixed numbers, and that means we have whole numbers accompanied with a fraction. For instance, I could have 1 and 1/2. That is a mixed number. 1 and 1/2. Hopefully you remember from arithmetic how we change a mixed number into an improper fraction and how we change an improper fraction into a mixed number. I'm going to use this as an example. The improper fraction is 9/4. How do I change that into a mixed number? This is indicating division. 9 divided by 4. 9 divided by 4. Another way to write division. 4 goes into 9 2 times. 2 times 4 is 8. 9 minus 8 is 1. And we put our remainder as the numerator of our fraction. So we would have 2 and 1/4. 9/4 is the same as 2 whole things with 1/4 left over. Then if I have a mixed number, how do I change that into an improper fraction? Again, these are all skills you need to have. We take 1 times the denominator, 1 times 2, and we add 1. We add the numerator. So you take the whole number, multiply it times the denominator, add the numerator. In other words, this will look like 1 times 2 plus 1 all over 2. So 1 times 2 is 2, 2 plus 1 is 3, all over 2, 3/2. 3/2 is an improper fraction, but it's another way to write 1 and 1/2. And I realize now I'm completely off the screen. There we go. You can see the rest of my work there. 1 times 2 plus 1 over 2 gives me 3/2. That's just a little review on some fraction work. Now, we are going to have to add and subtract fractions. Adding and subtracting fractions is always much harder than multiplying and dividing them. So if we are adding fractions, the one rule you have to remember is that the denominator must be the same. We can only add those things that are alike. So I can add thirds and thirds, but I can't add thirds and 17ths. I have to have the same denominator. So if your denominator is already the same, for instance, if I have 2/7 and I add it to 3/7, the rule is if the denominator is already the same, then all you have to do is add the numerator. So this becomes 2 plus 3 in the numerator all over the common denominator. In other words, you get 5/7. 2/7 plus 3/7 is 5/7. The same would go for subtraction. If you are subtracting fractions, you will need to have a common denominator. If you have 8/11 and you take away 6/11, you already have a common denominator. So you take the 8 minus 6, you put it all over 11, and you get 2/11. My biggest fear is that I'm going to get working on one of these and come up with a completely wrong answer, and all of you will know it, and I'll just be talking away. So hopefully that won't happen, but if it does, we're going to keep going. That's how you add and subtract fractions. You must have a common denominator. But what happens if you don't have a common denominator? If you don't have a common denominator, you're going to have to get a common denominator. Now, let's say